Hi guys, welcome to i5 Math. In today's video, we want to talk about prime factorization. The information in this video will be useful when we start adding and subtracting unlike fractions, which requires finding least common multiples and common denominators. So let's get started. As you probably already know, when we talk about whole numbers, we mean the natural, also called counting numbers, such as 1, 2, 3, 4, 5, etc., and 0. Excluding 0 and 1, the universe of whole numbers can be divided into two: the group of prime numbers and the group of composite numbers. A prime number is any number greater than 1 that can be evenly divided only by 1 and itself. For example, 3, 5, 7, and 11 are all prime numbers. When we say can be evenly divided, we mean divided without any remainder. On the other hand, a composite number is any whole number, again greater than 1, that can be evenly divided by more than just 1 and itself. For example, 8 can be divided evenly by 1, 2, 4, and 8. In mathematics, when we multiply two or more numbers together, we call these numbers factors, and the result we get we call a product. In the previous example of the composite number 8, the numbers 1, 2, 4, and 8 are all its factors. Here is the proof. 1 times 8 equals 8. 2 times 4 equals 8. 4 times 2 equals 8. 8 times 1 equals 8. Now, let's define factorization. When we talk about factorization of a whole number, we mean the breaking down of this number into a product of its factors. Let's look at some examples. The factors of 18 are 1, 2, 3, 6, 9, and 18. One possible factorization of 18 is 18 equals 1 times 18. Here, 18 is a product of two factors. Another factorization is 18 equals 3 times 6. Again, 18 is a product of two factors. A third possible factorization is 18 equals 1 times 2 times 9. Here, 18 is a product of three factors multiplied together. However, of all applicable factorizations of 18, the one that consists only of prime numbers as factors is called prime factorization. 18 equals 2 times 3 times 3. Both 2 and 3 divide evenly only by 1 and themselves. Therefore, they are prime numbers. Now that we know what prime factorization means, let's do two more examples together. For the first example, we will pick the number 78 and break it into its prime factors. Step 1. We take 78 and divide it by the smallest prime number, 2, again and again until we get a quotient, which is a decimal. Then we will divide by the next prime numbers, 3, 5, 7, etc., until we get a quotient, which is a prime number itself. So here we go. 78 divided by 2 equals 39. Great! We uncovered one prime factor of 78, namely the factor 2. However, if we try dividing 39 by 2 again, we would get 19.5, which is a decimal. So, let's try dividing by the next prime number, 3, instead. 39 divided by 3 equals 13. Awesome! We found another prime factor, the number 3. Can we keep dividing by 3, 5, 7 without getting a decimal? It doesn't look like it. As a matter of fact, because the number 13 is only divisible by 1 and itself, it is also a prime number. This leads us to step 2. We write the number 78 as a product of the prime factors we discovered. 78 equals 2 times 3 times 13. That's it. We completed the prime factorization of 78. Let's pick another number. How about 1260? Here we go. Step 1. Is 1260 divisible by 2? 1260 divided by 2 equals 630. Great, we found one prime factor. Let's divide by 2 again. 630 divided by 2 equals 315. Awesome, another prime factor. However, since 315 is not divisible by 2, let's try dividing it by 3. 315 divided by 3 equals 105. Great! Can we keep dividing by 3? Sure thing! 105 divided by 3 equals 35. We're almost done. By the way, this is as far as we can get by dividing by 3. Let's move on to the next bigger prime number, which is 5. 35 divided by 5 equals 7. Yay! We found out that both 5 and 7 are prime numbers, which means we're done dividing. The only thing left to do is step 2. We write 1260 as a product of the prime factors we came up with. 1260 equals 2 times 2 times 3 times 3 times 5 times 7. So here it is, the prime factorization of 1260. In summary, today we talked about prime and composite numbers. Also, we learned what is a prime factorization. Thank you so much for watching, guys. If you found value in this video, please click the like and share buttons. Also, consider subscribing to our channel and leaving a comment. Till next time.